Okay, welcome to the last video. In this one, you're going to see the elimination method demonstrated. So, if you remember from the systems we did earlier this year, as well as back in Algebra 1, elimination is where you add together your two equations in such a way that you cause one of the variables to cancel out. Now, when you're looking to eliminate a variable with nonlinear, you have to be careful because you've got your x to the second power and your x to the first power. So if you're trying to eliminate x, you would have to make sure you get rid of both of those, so you're just left with y. That can usually be difficult. So in these cases, you really want to try to eliminate your variable that is just to the first power, that doesn't have a variable being squared. So in this case, you see y is to the first power in both. So we want to try to eliminate that one. Now, in this example, it's set up nice and neat for you because you've got minus 1y plus 1y. Just remember from what we did earlier this year, if that's not the case, you may have to multiply your equations by some constant to get it so you have the same coefficient, so they'll cancel each other out. So in this example, you're going to see us just adding it together, but remember you can only do that if they're set up ready to cancel out. Otherwise, you might have to multiply it or multiply both equations by different numbers to get them so that they'll cancel out. So here's what we do. If we look at, in this case, we've got minus y plus y. So if we add these together, we're going to eliminate our y value. And what will happen is we'll be left with just a quadratic with our x variable. So let's go ahead and do that. So we line them up, we add them together, and remember, you want to line up all of your like terms. So your x squareds have to be added together, and your x's have to be added together. So when we add these, we get 3x squared, we get minus 3x, the y's cancel, and we get that equals negative 2. Now, to solve the quadratic, we want to go ahead and move negative 2 over, so we add 2 to both sides. So here's our quadratic now. Now, just like the previous examples, in order to find the solution, we have to solve this quadratic to get our x values. So we want to look at this and we want to see what method might be the best. Now, right off the bat, we've got an a value here, so completing the square, although we could do it, it may not be the most efficient. If we look at factoring, we've got 2, the only factors of 2 are 1 and 2, and with multiplying those, I don't see this being factorable. One thing that we can use is we can always use our quadratic formula. That's something you can always use, if you get something like this that's not easily factorable. So let's go ahead and set up our quadratic formula. And if we use the quadratic formula, which again you can go through on your own, but you get negative b, so we get 3, plus or minus the square root of b squared minus 4ac gives us 9 minus 24, so we get negative 15 over 6. Now, here's an interesting case because we see right here the negative under a radical sign. Remember, that's our discriminant right there. If you remember, when we have a negative discriminant, that means we have no real answers to this. Our solutions are going to be imaginary. Now, when that happens in a nonlinear system like this, when you have imaginary answers or non-real answers for one of your variables, that means that there are no solutions to this. So that means that there are no solutions to this system. If we look at the graph of this system, these parabolas never cross. And that's always possible. Remember, just like with our other systems, we could have no solutions, infinite solutions, or a unique solution. That's true here. So this is what it looks like. If you end up with an imaginary solution, you're going to have, it means your parabolas or your graphs never cross, and you have no solution. Okay? So again, make sure you're aware of that possibility that no solution can happen. Um, what I want you guys to do is try this example here. Go ahead and solve this problem by elimination. Go through the same steps that we went through before. Go ahead and solve this one, and go ahead and enter it in the text box that pops up now. Okay, now that you've done that problem, what I want you to do is, I've got 3 problems that I want you to practice using any method of your choice. So you can use substitution, graphing, elimination, whichever one you think would be best for each of these. So what I want you to do is, in addition to typing in your solutions, I also want you to tell me what method you chose. So elimination, substitution, or graphing. And just a quick little explanation of why. So what prompted you to choose graphing or substitution or elimination? Just a quick sentence would be sufficient. So again, I want you to solve each of these, label them clearly, write down the solutions, and then tell me what method you chose and why you chose it. Again, just a sentence would be sufficient for each one. Go ahead and enter those now.